Welcome to Scale Models. I'm your host Jason, and I do models as always. And now electronics. What's going on? Some microprogramming, some coding, and things like that. In this video, we're going to look at a project that I have taken on. It is a book that I've gotten from Brock Lemire's. It is Embedded Systems Design using the MSP 430FR2355 Launchpad, and I have one of these right here. I opened this in another video. I'll just take you another look at what's inside. A USB cable and this little micro controller system that has a microcontroller here and then a debugging system and programming system up on this side. So this is the development kit that goes with this book, and I am working my way through this book, and I want to share my adventures of learning this stuff with you. So I don't want to show any copyrighted material from his book, but I do want to share with you something on YouTube, and it is okay. I have to go back up here and nope. Let me just check something. Give me 1 second. I'll be right back. Okay, I'm back. I didn't have the microphone on this scene. So this is the website for Brock Lemire's. It's Digital Logic and Programming. He is out of, I believe, Montana State University. He is a fantastic teacher, and if you look here, he's got a lot of stuff on Intro to Electrical Engineering. If you want to just learn electrical engineering, that's cool. But he also has Digital Logic Design, which is another textbook that I'll talk about in a future video that I'm also going through. And then he has this embedded system design here, and you can look at the full playlist here. He talks about all the different chapters in the book, chapter 1, chapter 3, 4, 2. And you're like, where's chapter 1 or chapter 2? And if you look at this digital logic right here, this chapter 2 stuff talks about the binary system that is used in programming and stuff. So basically, chapter 1 is introduction, chapter 2 is digital logic, and there's a lot of math that goes through there. So he has the videos on the digital logic side. I'm doing both books at once, so I get both these and a little bit of combinational logic all in one. This is more a brief summary of combinational logic and sequential logic and things like that. Now we're looking at memory. It's a very long, and there's a bunch of questions you can answer at the end. It's a little bright. There we go. A bunch of questions at the end, and then a lot of questions at the end. I'm going to do all these questions, answers, and things like that. And then we look at computer systems and how computer systems work, questions. And then it starts talking about, on chapter 4, the MS-430 environmental system. Environmental. MSP. Launchpad. I don't know where I got environmental system at. That's just weird. It's a mixed signal processor, and he goes in chapter 4, and then he actually talks about all the different features on it. Like, here's a good layout of the board, and he talks about some of the programming stuff. I already released a video on getting all the software and going through, like in the beginning of the book, he tells you what documents you need to make sure you have downloaded. They're hundreds of pages long, but I saved them to a PDF to my computer under embedded systems, and I am working my way through through this book and his Introduction to Logic Circuits and Logic Design. I'm doing the Verilog version, not the HDL, because I know a little bit of Verilog, so I wanted to stick with what I knew. And, so far it's going so good. I had to slow down a little bit because we had my granddaughter for a week, so I wasn't able to do any of the studying. So I am going to knock out Chapter 2 in the Logic Design and Chapter 2 in Embedded Systems and give a brief overview of what I learned. So, I'm not going to show too much of the textbook, but I am going to go over my written answers that are in the form of questions, where the question is asked in the answer, so I can give you a brief overview of what I learned in the embedded systems design, and this will be also a reference for me to go back to and cover what I've learned. Like if I come in here to my chapter 1 here, let me go. Okay, so this, wow, things are messing up hardcore. So if I go and I open my chapter 1 in embedded systems. So I'm just going to open this up and I'll go over what chapter 1 was about. And basically, chapter 1 was about what's the difference between a general purpose system and an embedded system. And an embedded system, from what I grasped from the subject, was it is a system that has everything on one chip. It has firmware where it doesn't normally need to be updated, and it just runs like a toaster or a microwave or something that doesn't need any other processing units, memory, storage externally, doesn't really need external devices to communicate with. And with an embedded system, with a general purpose system, you have a CPU, a GPU, an APU, or RAM and memory and clocks and USB ports and all this stuff that you need to run like a computer or an operating system. And basically, I answered some of the questions. Like a general purpose system runs an operating system such as Windows. An embedded system is implemented on a single chip. An embedded system can cost less than $1. A general purpose system is designed to run any arbitrary software application the user desires. That's actually general purpose. General purpose system can cost hundreds to thousands of dollars. An embedded system has software called firmware that highlight that it is rarely changed after being deployed. An embedded system is also called a microcontroller because it controls the subsystems around it. An embedded system has a real-time operating system, but the OS primarily acts as a task scheduler. A general purpose system has a tight coupling between hardware and software, which optimizes its operation for the application at hand. So with general purpose, you can run multiple different types of applications and add new applications because the hardware is designed to add new things, and it doesn't know what's going to be added, but it knows how to deal with something that is added with the driver or things like that. An embedded system is the most popular computer on Earth. They are everywhere. They are in tons and tons of things. A general purpose computer would be better suited for running the Windows operating system. A general purpose computer would be better suited on running an Xbox. See, now, I put general purpose would run an Xbox, but I think that is an embedded system. I think the APU in a Xbox is more of an embedded system because it has external memory like RAM and stuff and an external hard drive, but it basically just runs the Xbox and then it runs the software. It downloads from the games, and it gets everything from the games. So I was a little iffy on that. I put general purpose computer systems, a general purpose computer, but I'm not sure that could be an embedded system. I'm not sure. Leave a comment below if you think that should be embedded. And then I have an embedded computer would be better suited to run the radio in a car, because really all you're doing is swapping between some channels and some frequencies. An embedded computer would be better suited for controlling a satellite. A satellite runs a set of tasks. It doesn't really get new applications uploaded to it. It basically just transmits and receives commands. An embedded computer would be better suited for running a wireless router. Again, no new applications on the router. It's just basically a hub that transfers data. A general purpose computer would be better suited to run a server farm on the Windows platform. That's obvious. A general purpose computer would be suited for running an iOS on a laptop. Again, a laptop would be general purpose. A general purpose computer would be better suited for a Linux workstation used to develop for an MCU, microcontroller unit. So if you're going to be programming microcontrollers, you're going to need a general purpose computer. It's going to be hard to program a microcontroller with just an embedded chip, embedded computer. And then an embedded computer would be better suited for running a video doorbell, because basically you're pushing a button and it's transmitting a bit of video. So you can see the differences between general purpose and embedded, where embedded is very, very simple. The code is written, the code is placed in the chip, uploaded, downloaded to the chip, whatever your word you want to use, and then it is installed in the device, and then that firmware is pretty much not messed with anymore, like in a toaster. Or toaster was the example he used a lot, so I'm using toaster. You don't plug in your toaster to update it. And the interesting thing is, with learning the digital systems versus analog systems in the other book I'm going through, a toaster is a good example of something that's that's evolved over time from an analog to a digital system. Back when I was a kid, all toasters was a lever. You plug it in the wall, you have some heating coils, you push a lever down and it turns the heating coils on for a set number of ticks. You can actually hear it ticking, and then when it's done ticking, it releases the latch and the toast pops up and the heating coils go off. So it didn't even have a computer chip in it. It didn't have any kind of system like that. Now you have toasters with digital readouts, temperature sensors, and you have little chips, little embedded chips that have just a small operating system on it that gathers data from the temperature sensors, the time settings, the switch that shows that it's been pushed down. So that is involved from a completely analog system to a digital system using an embedded system technology. And that was the reason why I went with doing both books at one time. I'm really hoping that he does another book on like an intro to electrical engineering, because this guy's fantastic. He writes impeccably and he explains things very well, and his videos are very thorough and very understandable, and I would love him as a teacher. He seems fantastic. So this isn't sponsored by him. I hope it's okay that I'm doing this. I'm amazed at how great these books are. The quality, the way it's written, very easy to understand, lots of examples. So it's a good, interesting system. So this is my review of Chapter 1. We haven't got into the MSP 30 yet. I don't want to show any images from the book other than just flipping through it quickly. But there are some pretty neat layout images of flow charts and stuff, layouts of how an embedded system works. If you guys check out his YouTube channel, just the first video that is in this book, let me just get this up here and then I'll swap it over. This first this first video, embedded systems overview, it's 16, 17 minutes long, and it is a fantastic overview of what an embedded system is compared to a general purpose system, or like what we consider a PC. So it's absolutely fantastic. I can't say more good things about this. Like I said, not a sponsorship. I bought this textbook. It's not a cheap textbook, but I mean it's worth the price I paid for it. And then I had to get this off DigiKey, so it's, yeah, I'm enjoying it. It entails a little bit more work to grasp the concepts, and I am answering all the questions in a Word document, so I have it for reference, so I can go over what I learned in a video after I go through each chapter of the book. So that is my overview of this system that I'm doing and chapter 1. I'm going to be doing my digital logic one next, so check that one out and stay tuned for that. That's going to do it for this video. Here's the links to social media, and here's the links to my Patreon page if you so choose. Thank you guys so much, and I hope you have a fantastic